I want to take a look at solving some more trig equations, but of a different style than the ones that we're used to. We've been solving equations like cosine x equals root 2 over 2 for x being between 0 and 2 pi. We did that by using inverse cosine, or even just thinking what value of x would the cosine of x be root 2 over 2. And with our familiarity of the unit circle, we know that the cosine of pi over 4 is square root of 2. And then we thought about the unit circle, and that because we're going for all x's between 0 and 2 pi, that means we got to go all the way around the circle, take one trip around the circle. And cosine is positive in the first quadrant and also in the fourth quadrant. So we thought about what is the pi over 4 angle that is in quadrant 4, and that would be 7 pi over 4. And that was our thought process through this type of problem. Now, I want to also look at this in terms of its graph. We can solve that trig equation in a graphical sort of way because the red curve that I have here, that is y equals the cosine of x. And then the line that I have in blue, that's the line y equals square root of 2 over 2. And so what we know about systems of equations is that the point of intersection of these two graphs is going to be when cosine of x is equal to root over 2 over 2. That'll be right here and right here. So those x values of those points happen at pi over 4 and over here at 7 pi over 4. So what about when the equation changes from cosine of x to cosine of 2x is equal to root 2 over 2? Now we can use our instinct and see how far that takes us. We know that cosine is root 2 over 2 when that 2x is going to equal pi over 4. And thinking about going all the way around the circle once, that'd be also at 7 pi over 4. Then, well, x would just be dividing both of those by 2. So pi over 4 divided by 2 is pi over 8. And 7 pi over 4 divided by 2 is 7 pi over 8. So we would anticipate that these would be our two solutions. But when we look at the graph of this situation, something should jump out to you right away. Again, in red, I have y equals the cosine of 2x, and in blue, it's y equals root 2 over 2. So their intersection is going to be the solutions. And what we notice is this time, we should be ending up with 4 solutions, not just 2. And in fact, when we take a closer look, this one does happen to be at pi over 8. And this one is at 7 pi over 8. But there's 2 more that we need to figure out. And we can just kind of, reason things out graphically that, this pi over 8 is pi over 8 units past 0. And since cosine of 2x is periodic, we can go that same pi over 8 past pi. And that would mean that this is at 9 pi over 8. And similarly, this 7 pi over 8 is pi over 8 short of pi. So our last answer's got to be pi over 8 short of 2 pi. So that would be 15 pi over 8. And that's a good way to reason your way through this problem. Another thing that I want to look at, though, is going back to this y equals cosine of 2x. And what does that 2 do to the problem? If you remember when we were graphing sinusoids, that a 2 in that position changed the period of the cosine function. And what it did is take the normal period of 2 pi and divided it by 2. Another way to look at that is that from 0 to 2 pi, so over this entire interval, what we end up with is 2 waves instead of the normal 1. See, here is our first wave. and then we're left with our second wave. I want to use that idea in order to solve this equation algebraically. Check this out. Because x is in between 0 and 2 pi, that would mean that 2x would have to be in between 0 and 4 pi. So when I'm solving this equation, cosine of 2x is equal to root 2 over 2, and we think, well, that would mean cosine would have to be pi over 4 and 7 pi over 4. That's right for one trip around the circle. But because we have to let 2x go from 0 to 4 pi, that means we have to take another trip around the circle. What I mean by that is that we found out that 2x has to be pi over 4 right here and 7 pi over 4 down here. So for this pi over 4, if I was going to take another trip around the circle, that much is pi over 4. But if I go around the circle again, the coterminal angle for that is going to be that pi over 4 plus 2 pi more. So 9 pi over 4. And similarly, for this 7 pi over 4 angle, if we went another trip around the circle, we would add another 2 pi to the 7 pi over 4, which would be 15 pi over 4. So we see that the first two answers we came up with are our first trip around the circle. The next two are for the second trip around the circle. Once we have all four of those, now we go ahead and divide each one of those answers by 2. So that x is going to be pi over 8, 7 pi over 8, 9 pi over 8, and 15 pi over 8. So when we look at cosine of 3x now is equal to root 2 over 2, how many solutions do you think that we should get? Well, when we look at things graphically, for y equals cosine of 3x, that 3 takes a normal period of 2 pi and cuts it into a third. All right, so that we have 2 pi over 3. When we look at the graph, we see that we should end up with 1, 2, 3, 4, 5, 6 different solutions in between 0 and 2 pi. That's because when we look at breaking up the cosine of 3x, that's one period. Then we would go to the second period and then to the third period. Since our solutions x have to be between 0 and 2 pi, that would mean that 3x would have to be in between 0 and 3 times that, or 6 pi. So we're going to have to take 3 trips around the circle now to find our solutions. So cosine of 3x is equal to root 2 over 2 means that 3x would have to be pi over 4 or 7 pi over 4. That's the first trip around the circle. So we have to take both of those and go around the circle one more time. So to each one of those, I'm going to add another 2 pi. So remember, 2 pi is 8 pi over 4. So when we add 8 pi over 4 to each of these, we'll get 9 pi over 4 and 15 pi over 4. And then we have to go around the circle again. This is the second time around. So we add that 8 pi over 4 one more time. So 9 plus 8 is 17 pi over 4. And 15 plus 8 is 23 pi over 4. So now we have our 1, 2, 3 trips around the circle. Once we've gone all 3 times around the circle, now we can divide each of our answers by 3, which will leave all of the numerators the same, but our denominators will turn to 12ths. And one thing I want to point out is notice that our last value, 23 pi over 12, that is still smaller than 2 pi. All of our x's are supposed to be in between 0 and 2 pi. Of course, looking over our solutions, we see that what we should do is take this 9 pi over 12 and simplify that into 3 pi over 4. And we should do the same thing with 15 pi over 12 and simplify that one into 5 pi over 4. Then we have all 6 of our solutions. Let's try one more. If x goes between 0 and 2 pi, then where does 0.5x have to go? Well, since multiplied x by a half, we have to take half of that 2 pi, so we're going to go up to pi. Thinking about our solutions now, cosine is root 2 over 2 when the angle is pi over 4 and 7 pi over 4 for one trip around the circle. However, since we're dealing with half of an x, we're not taking one entire trip around the circle, we're taking a half of a trip around the circle. So we don't need that second solution. This is the only one. So now we have 1/2 x is equal to pi over 4. To solve that, we multiply both sides by 2. And x would be equal to pi over 2. Graphically, if you wanted to see that, because that 0.5 in front of the x actually stretches the period to make it twice as large instead of twice as small, we only get half of a wavelength in the normal 0 to 2 pi range. So our solutions, there's only going to be this one, which kind of looks like it happens at pi over 2.